Here we have the 2018, this is question 1, paper 2, junior cert higher level. So the diagram below shows a circle with centre O. The 5 points A, B, C and D, C, D and E are on the circle. So AB is a diameter and DE is a diameter. Also we're told that OE is 40 degrees, which I've labelled in here. And then the angle X, Y and Z the angles are labelled. So we're asked to write down the size of the angle X. So the first thing that will be easy when the theorem that we need to know to get the size of the angle X is if we have two angles and they're vertically opposite, well, vertically opposite angles are equal. So X is vertically opposite this angle here of 40. So X is going to be equal to 40 degrees. And that is because vertically opposite angles are equal. And then we're asked to work out the size of angle Y. So now we know that X is equal to 40. So if we're looking at this as a triangle, well, this is the radius. This is the radius because it goes from the centre to the edge, the centre to the edge. So this is the same length as that length because the radius is always going to be the same length. So now we have an isosceles triangle. In an isosceles triangle, the two sides that are equal, well, the angles opposite those sides are also going to be equal. So they're going to be the exact same angle. So 40 plus 2 of those angles will have to give 180. So say if I let those angles equal P. So if I let that equal P and that equal P. So 40 plus 2 of the P is going to be equal to 180. So I just randomly picked P. So 2P is going to be equal to 180. Subtract 40. So 2P is going to be equal to 140. So P is going to be equal to 140 divided by 2. So it's going to be 70 degrees. So now I can say that the P that I had labelled P was actually angle Y. So angle Y is equal to 70 degrees. So now I know that this angle here is 70 degrees and also this angle here is 70 degrees. And then the next part is work out the size of angle Z. So angle Z is here. So what I'm going to need to know for this one is if I have two angles and they are standing on the same arc. There's a few different ways that this can be presented. So it can look like something we're used to, like it can look like, say, we're used to seeing it kind of like this, so this would be more obvious for us. So this angle here, say that's X, well this one here will be 2X, and they're both standing on this arc. Another way we can think about it is, say if we have a line that goes through the center and it's 180 degrees, well the angle at the circumference is going to be half that, so it's going to be 90 degrees. And the only other way it really can be presented is, say if we have a circle and then say they're both at the same kind of end of the circle, so they both start at a different kind of edge, but they're both still on the same arc. So they're both on the same arc. They're both on this arc. But this angle here is going to be 2 by the 2 of this angle, which is here. So looking at that, whatever the total of, say if I have this diagram here, this whole angle here, so from here all the way over here, is going to be double the angle Z. So all I have to do now is just get what's missing in this part here. But say this is a straight line, so 40 plus whatever is in here is going to add to give 180. So this here must be 140. So if I want to get what, I just have to add them all together to get the total. So 40, so it's going to be on a reflex angle, so 140 plus 40 plus 40, so that's going to give me 200. So this angle here altogether is going to be 220. So then if I want to get what Z is, it's going to be half that. So 220 divided by 2, which will give me 110. So my angle Z is going to be equal to 110 degrees, and that is the last for that question. Thank you.